Hello everyone. Today we are going to talk about mathematical terminology or mathematical proof, which is a list of statements in which every statement is one of the following, which is at first an axiom, and then a derived previous statement, and then after that a previously derived theorem. Mathematical terminology also has a current hierarchy, which first is a preposition that means is a true statement that we are trying to prove, while next are a theorem, a proposition that are considered to be extremely important to prove. After that, we have a lemma, which is a preliminary proposition that is used in the proof of the theorem. And lastly, a corollary, a true statement that is a simple deduction from a theorem or proposition itself.
Construction method definition: a technique for dealing with statements in the backward process that have potential quantifier, which is there is, there are, and there exists. It is written in the standard form: there is an object with a certain property such that something happens. For guidelines, first we write a statement for A and B. Then we identify existential quantifier as a key. The third one, we identify object from backward and it become a forward statement, which is A1. Then we use hypothesis together, and lastly we establish a constructed object. Example question 1. Prove that there is an integer x such that x squared plus x over 2 minus 1 over 2 equal to 0 is the constructed object unit. For analysis of proof, A, we put the equation which is x squared plus x over 2 minus 1 over 2 equal to 0. B, there is an integer x. A1, we put 2x squared plus x minus 1 equal to 0. A2, x equal to 1 over 2 or x equal to negative 1. For A3, x equal to negative 1 is the only integer solution for the quadratic equation, and A3 is equal to B. For a condensed proof, given a quadratic equation x squared plus x over 2 minus 1 over 2 equal to 0, by factoring the equation yields the value of x equal to 1 over 2 or x equal to negative 1 is the only integer solution for the quadratic equation. Thus, the constructed x is unique.
Okay, and next we move to question 2. The question: if the rectangle RST with side of length R and S and hypotenuse of length T, justify T equal to square root 2RS and the length RST is isosceles. So we know that from this equation we get if A then B. So B is what we want to prove it. So isosceles means length of R and length of S have equal length. So first theorem Pythagoras, T equal to square root 2R, and then we find area R squared over 2, and then we compute it. So we get T squared over 4. So from this question, we want to answer. So first we write analysis of proof and write A and B that we get from the question. So here is we want to prove B. So we have to find B1. So the angle of RST equal to T squared over 4. So B2 RS over 2 equal to T squared over 4. So from the A we know that T equal to square root to RS, we just square it T. So we get T squared equal to 2RS, and then we find A2 rs over 2 equal to t squared over 4. So from this we know that b2 and a2 is equal. So the proof is complete. So from this we know that by the hypothesis t equal to square root to rs, so we get t squared equal to 2rs, or equivalent rs over 2 equal to t squared over 4. So that's the area of the right triangle. RST is t squared over 4 as false hypothesis, and hence the conclusion is 2. So consequently the triangle RST is equal to this step or we get to next question.
Next, we are going to go over example 3, which is to prove that if s and t are rational numbers and t isn't equal to 0, then s over t is a rational number. Our analysis of proof, which is A, our hypothesis, is to show s and t are rational numbers and t isn't 0. B is going to be our conclusion, where s over t is a rational numbers. Our B1 is going to be there are integers P and Q with Q isn't 0 such that S over T equal to P over Q. Our A1 is going to show to construct integers P and Q, while B2 is to show that S over T equal to P over Q. A2, which is going to derive from A1, is going to let S equal to A over B and T equal to C over D, where A, B, C, D are integers with B, D isn't equal to 0. After that, it's going to be S over T equal to A over B over C over D. Our A3, which are going to simplify from A2, is going to be A over B multiplied with D over C. A4 is going to be S over T equal to P over Q, where P equal to AD and Q equal to BC isn't 0. This proves that A4 is equal to B2. After that, we are going to show that our condensed proof. Because S and T are rational, then they are integers A, B, C, and D are integers with B, D isn't equal to 0 such that S equal to A over B and T equal to C over D. Since T isn't equal to 0, then C isn't equal to 0. Constructing P going equal to AD and Q equal to BC isn't equal to 0, it follows that S over T equal to A over B over C over D. It's going to be AD over BC and going to be equal to P over Q. Hence, S and T is rational, thus completing the proof and our analysis of proof and our conclusion itself.
Lastly, for the summary, what you can get from this video is first, mathematical terminology provide a precise and universal language to describe mathematical concept, idea, and relationships. Second, help us better at understanding, explain, and discuss mathematical terms. And lastly, help us develop mathematical structure such as analysis proof and solving equations. So that's all from us. Thank you. Assalamualaikum.